So this table over here gives the percentage reflectance as recorded by multispectral scanner of Landsat. So Landsat is satellite that has a multispectral scanner mounted on it. Or what a multispectral scanner does is that it acquires data using a scanning system. So जो हम लोग पहले we were discussing, um, yeah, which employs a sensor that sweeps over the terrain to build up and produce a 2D image of the surface. So see, you're not taking an actual photograph, you are taking reflectivities, and based on that, it is drawing up a 2D image of the whole area manually. So a scanning system used to collect data over a variety of different wavelength ranges is called a multispectral scanner. So why it's called a multispectral scanner is because it can collect data over different wavelength ranges. So bots are different objects which give stronger reflectivities at different wavelengths. So it can classify based on that. On different bands of wavelength, it can collect data. And MSS systems are carried in satellites and can operate within wavelengths from about 0.3 to 14 millimeters. In a manner similar to the way humans detect colors, MSS units isolate incoming energy into discrete spectral categories or bands and then convert them into electric signals that can be represented by digits. And the digits are associated with pixels of various bands of energy, and then it creates a digital format. So जो हमने पहले बात की थी कि what is the objective of gathering information? अगर आपका objective ये है that you want elevations, so you would choose LiDAR. अगर आपका objective है that you want to get different measurements, so फिर photography is probably the best remote sensing sensor. But if you want image classification और if you want object classification on the ground, जिस तरह आपने अभी मैंने weed की बात की थी, or if you want to see the extent of a particular vegetation, a particular crop, उस case में scanning would be the best because it can classify that, it can analyze it, and it can measure it as well. कि on the whole area that you've scanned, how much of the area was covered by a particular vegetable crop. Yeah, for whole area that we've covered, what is the total area covered by a lake, let's say. So it can actually give you that result. So it basically depends. So over here, it's an image drawn up by a multispectral scanner. So it scans the area, takes the reflectivities of objects, और जहां जहां एक particular reflectivity आ रही है, it then classifies it based on that. So जहां जहां पे there would be houses of a particular material, उनकी reflectivities would be same, and it can classify कि over here we have the covered area in terms of houses, over here we have a lake, over here we have a green area. Let's say. So over here we have an example of multispectral scanner which gives geologic formations over large areas, the number of lakes in the area, relative positions, shapes, acreages. So based on that classification, अगर आप image लेते हो ना using a camera, so you have to do manual classifications and then you have to manually measure the area. यहाँ पे क्या हो रहा है कि आपने एक फीचर उसको बता दी है कि यार दिस ऑब्जेक्ट हैज अ पर्टिकुलर सिग्नेचर, और बेस्ड ऑन दैट जहां जहां उसको वो सिग्नेचर मिलेगा इट वुड क्लासिफाई इट on its own, and then it can measure the extent of its coverage on its own. So it's better in that sense. So this is 1 meter resolution MSS image. The resolution depends on again the height of the satellite and how advanced that sensor is. So over here, ये आपको picture लग रही है, which is actually a picture taken by a camera in black and white, but it's actually a picture drawn up by a multispectral scanner by scanning, by sending out EMR, taking the reflections, classifying objects, and then drawing up uh, a 2D image of an area. So the applications of MSS, something that we've discussed as well, it depends on the objective. and then you can apply it to prepare site maps and preliminary plans for proposed construction projects. आप classify कर सकते हो कि यार where do we have a particular type of soil, what are the geological formations, बहुत सारी object classifications आप कर सकते हो. Again, if you take just a picture won't classify कि यार what is the type of soil, and MSS would do that for you. Or you can see here where you have favorable soils, कहाँ पे top layer किस type की है and all of that. Planning for locations of stations in large area control surveys or planning aerial photography, um, generating detailed information layers such as land cover, hydrography, transportation networks, using the images as reference frames for performing GIS. So I told you that remote sensing can be an input for GIS. So MSS images can actually be your input for GIS maps. Then we come to LiDAR, light detection and ranging. So what LiDAR does is that it's basically a laser emitting sensor. So it shoots out lasers and then it sees here how much time the laser took to return back. And based on that, it can draw your distance maps from that particular height जहाँ पे आपने scanner लगाया हुआ है. So these systems, which are carried in airborne vehicles, consist of a laser scanning device and a navigation system. So usually you have a navigation system installed concurrently क्योंकि when you shoot out a laser, it will give you elevation of a particular point. और वो point कहाँ पे located था? Alternate navigation device जो साथ होगी navigation system होगा, it can store that data into that uh, latitude longitude coordinate. ये coordinate था, उसकी ये elevation है, so the two systems can run concurrently. As the aircraft flies around its trajectory, laser pulses are transmitted towards the terrain below, reflected from the ground or objects, and detected nearly instantaneously. So, Joe, the function of EDM is seen over here as well. From these pulses, distances and angles to reflective objects are determined. Concurrently, the inertial navigation device records the aircraft's location, X, Y, and Z coordinates, and then it can locate which location had a particular elevation. So, uh, it uses light in the form of pulsed laser. So, it would be an active remote sensing system. These light pulses combined with other data recorded by airborne system generate precise 3D information from the shape of the Earth and surface characteristics. So ये difference है between a photographic image and a LiDAR. Photographic image क्या करे? It just gives you a picture of how you would see it by your eyes. LiDAR क्या करे? LiDAR classifies um, different objects based on their elevation. So the objects which are at a higher elevation, it would give it a different theme. Just come elevation पे होंगी a different theme, and between that, it can classify elevation of different objects based on their relative heights. Someone was also talking about the accuracy. So they've written over here that the accuracy is possible by LiDAR devices are currently in the range of 10 to 15 centimeters. So then again, अगर आपका localized project है, obviously you won't be going for LiDAR. It would be of no use. लेकिन अगर आपका preliminary survey है, आपने let's say एक dam के लिए storage capacity निकालनी है एक watershed में, LiDAR would help you क्योंकि इसकी accuracy सिर्फ जो off है it's by 10 to 15 centimeters, which is nothing. So for very accurate survey or for जो accurate survey आपको चाहिए होता है, that's also for a very localized project और उसका scope बहुत कम होता है. काम का जो पूरा मैग्नीट्यूड है वो कम होता है. So in that case, your localized conventional field survey equipment would work. But if you want to do it for a broader scale, for a broader range, where accuracies of 10 to 15 centimeters can work, then obviously there is no match for LiDAR. So then again, a LiDAR can help you to make digital elevation models. Um, Contour maps give you the same thing. These models give you the same thing. Both have different processes by which they are derived. DEM models can then be used to make contour maps as well. But you can see how precisely and how quickly a LiDAR can make digital elevation models. So two types of LiDARs are used, topographic and bathymetric. Topographic LiDARs typically use a near-infrared laser to map the land, while bathymetric LiDAR uses water-penetrating green light to also measure seafloor and riverbed elevations. So हमने बात start ही यहाँ से की थी कि different electromagnetic radiations can work better in different objects or atmospheric layers or water. So a LiDAR with a particular wavelength would work better in the atmosphere, but a LiDAR would with a particular wavelength would work better underwater. So अगर आपने seabed elevations find करनी है, river bed elevation बनानी है, in that case, you would use bathymetric LiDAR. So LiDAR systems allow scientists and mapping professionals to examine both natural and man-made environments with accuracy, precision, and flexibility. And scientists use LiDAR to produce more accurate shoreline maps. You can see that shoreline पे if the water is coming into the shore or out of the shore, if it's receding or advancing. So based on that, you can predict कि इतने सालों बाद the water would reach this much distance on the shore. Make digital elevation models for use in geographic information systems. So आपके जो GIS models हैं उसके अंदर again a LiDAR elevation map can be an input to assist in emergency response operations and in many other applications. So आपके जो GIS maps हैं they can be different based on the application. They can be Google Map is a GIS map, Google Earth is a GIS map. How it's a GIS map? Because remote sensing say what did you get? You get uh, let's say Google Earth के लिए you got pictures stitched together, you got a topographic image. लेकिन उसके बाद when you enter information for let's say a hospital या for university, आप उसके अंदर जाके you can rate it. अब तो आप menus देख सकते हो restaurants के. You can get minimum live traffic updates. You can get minimum time for distance coverage between 2 points. So वो सारी information जो आप उसमें डालते डालते जा रहे हो, that's a GIS map which keeps getting upgrading. लेकिन उसमें जो basic input थी सबसे पहले वो थी from remote sensing. Some application of LiDAR include topographic mapping, urban planning, coastline management, pollution modeling, forestry planning and management, flood modeling, and transport modeling. So in some cases में wherever an elevation difference can help you, in some cases में a LiDAR can be of use. So in these slides, I've already included LiDAR and multispectral scanner. बाकियों के बारे में I've given a brief introduction. But based on the objective, different satellite missions have been sent and they're gathering different informations. Some missions have been sent for especially for weather. Some are sent specially for taking pictures, photographs, so for different reasons. Um, Now I'll be giving some examples. So you don't have to memorize these. So just for your information, कि Landsat 7 is a very famous satellite mission sent by NASA. जिसमें we talked about that there's a multispectral scanner involved and it can make those 2D maps. QuickBird was sent in 2001 और जो आप pictures देखते हो, so this is a picture which is taken by QuickBird and you can see कि how good the resolution is. That means it uses a very high resolution camera. And second, its elevation from the earth is not too much. क्योंकि as you keep on giving it more elevation, the resolution on your pictures would keep on decreasing. Similarly, Terra satellite is a very famous satellite which has been sent for monitoring the climate change. So इसका जो मकसद है, it would be taking all of those measurements which are related to climate, um, hurricane movements, predictions, atmosphere के अंदर ozone layer की depletion, pollution level in the atmosphere, all of that measured by these satellites. Similarly, World View 4 again, it basically takes pictures. So what I wanted to tell in the beginning was that if you go to these websites, for example, NOAA एक website है related with the oceans and seas. Similarly, जो Terra satellite, the input it's giving you, um, the owners of the satellite are uploading it on their website. Similarly, you can get very clear pictures from the websites of the satellites which have been sent for that purpose. तो गूगल अर्थ से भी आप ऑब्वियसली एक स्नैपशॉट तो ले सकते हो, बट यहाँ पे अगर आप देखो रेजोल्यूशंस बहुत बेहतर हैं. सो डिपेंडिंग ऑन द पर्पस उसके सेंसर उसका डिजाइन होते हैं, उसकी एलिवेशन उसका सेट होती है, बट अ लॉट ऑफ दिस डेटा इज फ्री. सो इफ यू थिंक यार हाउ कैन वी यूज द रिमोट सेंसिंग इंफॉर्मेशन, तो जो जीआईएस मैप्स अगर आप बना रहे हो उसमें अ लॉट ऑफ दैट इंफॉर्मेशन इज फ्री एक्सेसिबल फ्रॉम द वेबसाइट्स. आप सर्च करो गूगल पे remote sensing data, you'll get different links on websites पे जाके you put in the coordinates or the locations जिसकी आपको information चाहिए, वहां से you can get a lot of information which can be your input to GIS maps. So this is something for you to read, how dynamics are changing in surveying, what is the way forward, how remote sensing is changing the way we perform data collection and everything, and how it helps in analyzing it. So